Good morning. So I purchased some microchip PIC10F200 chips on eBay. Here is the ad. It says the brand is Wakatsing. I don't know if that's going to be a problem, as some other microchip chips I bought before didn't quite work the way they were supposed to. Well, they sort of did. Never mind, the ones I bought before were actually microchip brand. Anyway, without wasting too many more words, I'm just going to read the data sheet for the microchip PIC10F200 and try to cover information that I think is interesting and important. Microchip PIC10F200 6-pin 8-bit flash microcontrollers. Devices included in this datasheet: the PIC10F200, the PIC10F202, PIC10F204, PIC10F206. High performance RISC CPU. Only 33 single word instructions to learn. All single cycle instructions except for program branches, which are 2-cycle. 12-bit wide instructions, 2-level deep hardware stack, direct, indirect, and relative addressing modes for data and instructions, 8-bit wide data path, 8 special function hardware registers, operating speed, 4 MHz internal clock, that's good to know, 1 microsecond instruction cycle. Special microcontroller features: 4 MHz precision internal oscillator, factory calibrated to plus or minus 1%, in-circuit serial programming, ICSP, in-circuit debugging, ICD support, power on reset, device reset timer, watchdog timer, WDT, with dedicated on-chip RC oscillator for reliable operation. Programmable code protection, multiplexed MCLR input pin, internal weak pull-ups on input-output pins, power-saving sleep mode, wake up from sleep on pin change. Low power features: CMOS technology, operating current less than 175 microamps at 2 volts, 4 megahertz. Typical standby current equals or is 100 nanoamps at 2 volts typical. Low power high speed flash technology, 100,000 flash endurance, and less than 40-year retention. Fully static design, wide operating voltage range, 2 volts to 5.5 volts, wide temperature range. Peripheral features: 4 input-output pins, 3 input-output pins with individual direction control, one input only pin. I was warned about that. One of the pins is an input only. High current sink/source for direct LED drive, wake on change, weak pull-ups, 8-bit real-time clock counter, TMR0 with 8-bit programmable prescaler. Peripheral features: I don't know if my chip is included, but it's talking about the 204 and 206. And I might leave it because it seems to cover similar info. Table 1.1, PIC10F200 memory and features. So I guess it applies to all of these. PIC10F200 program memory, flash words 256, data memory, SRAM bytes 16, input output 4 pins I guess. Well, I guess it was 3 outputs, and anyway, one was an input only. I'm not sure I'm getting that right though. Timers 8-bit, no comparator. SOT23, which stands for small outline transistor. I guess that's more like a surface mount maybe. So here's an SO23 size comparison. Anyway, this is the one I have, I think. So pin 1, I'll zoom in. Pin 1 is not connected. Pin 2 is VDD. Okay, I forgot where I was. But anyway, VDD is the voltage supply and VSS is the ground. VSS is the most negative supply terminal for an IC. I guess I'll go in order. 1, 2, 3 is GP2, or T0 clock input. FOSC4. Pin 4 is GP1, CSPCLK, so that's clock maybe. I'll probably find out more as I read. Pin 5 GPO or GP0, ICSP DAT. Pin 6 is not connected. And pin 8 is GP3 mClear VPP. General description: the PIC10F200 and other devices from Microchip Technology are low-cost, high-performance, 8-bit, fully static, flash-based CMOS microcontrollers. They employ a RISC architecture with only 33 single-word, single-cycle instructions. All instructions are single-cycle, 1 microsecond, except for program branches, which take 2 cycles. These devices deliver performance in an order of magnitude higher than their competitors in the same price category. The 12-bit wide instructions are highly symmetrical, resulting in a typical 2-to-1 code compression over other 8-bit microcontrollers in its class. The easy-to-use and easy-to-remember instruction set reduces development time significantly. The PIC10F and other products are equipped with special features that reduce system cost and power requirements. The Power On Reset (POR) and Device Reset Timer (DRT) eliminate the need for external reset circuitry. INTRC (internal oscillator mode) is provided, thereby preserving the limited number of I/O available. Power-saving sleep mode, watchdog timer, and code protection features improve system cost, power, and reliability. The PIC10F devices are available in cost-effective flash, which is suitable for production in any volume. The customer can take full advantage of Microchip's price leadership in flash programmable microcontrollers while benefiting from the flash programmable flexibility. The PIC10F products are supported by a full-featured macro assembler, a software simulator, an in-circuit debugger, a C compiler, a low-cost development programmer, and a full-featured programmer. All the tools are supported on IBM PC and compatible machines. Applications: the PIC10F devices fit in applications ranging from personal care appliances and security systems to low-power remote transmitters and receivers. The flash technology Flash technology makes customizing application programs, transmitter codes, appliance settings, receiver frequencies, etc. It's extremely fast and convenient. The small footprint packages for through-hole or surface mounting make these microcontrollers well suited for applications with space limitations. Low cost, low power, high performance, ease of use, and input-output flexibility make PIC200 devices very versatile, even in areas where no microcontroller use has been considered before. Example, timer functions, logic, and PLDs in larger systems and coprocessor applications. Table 1.1 PIC10F200 Clock. Maximum frequency of operation 4 MHz in all of the different chips. I'll just cover the chip I have. I guess I've read this already. Flash program memory 256, data memory 16 bytes, timer module TMR0. Wake up from sleep on pin change, yes. Comparators, it doesn't have one. Input-output pins, 3 input-only pins. They all have just one. Internal pull-ups, they all have it. In-circuit serial programming, yes. Number of instructions, 33. Packages, dip, everything else, I guess. The PIC200 and other devices have power on reset, selectable watchdog timer, selectable code protect, high input-output current capability, and precision internal oscillator. These devices use serial programming with data pin GPO and clock pin GB1. This information came up in a previous datasheet, and I don't think I want to read this again. Basically talks about device varieties, product identification, different programming devices, and the company can offer services around that. And what was this about? Yeah, more programming service information, password protecting, and serial numbers and things. Architectural overview. The high performance of the PIC10F200 series devices can be attributed to a number of architectural features commonly found in RISC microprocessors. To begin with, the PIC series devices use a Harvard architecture in which program and data are accessed on separate buses. This improves bandwidth over traditional von Neumann architectures where program and data are fetched on the same bus. Separating program and data memory further allows instructions to be sized differently than the 8-bit wide data word. Instruction opcodes are 12 bits wide, making it possible to have all single-word instructions. A 12-bit wide program memory access bus fetches a 12-bit instruction in a single cycle. A two-stage pipeline overlaps fetch and execution of instructions. Consequently, all instructions, 33, execute in a single cycle, 1 microcycle at 4 MHz, except for program branches. The table below lists program memory, flash, and data memory, RAM, for the PIC10F200 devices. Table 3.1, device PIC10F200, program 256 by 12, data 16 by 8. The PIC10F devices can directly or indirectly address its register files and data memory. All special function registers, SFR, including the PC, are mapped in the data memory. The PIC10F200 devices have a highly orthogonal symmetrical instruction set that makes it possible to carry out any operation on any register using any addressing mode. The symmetrical nature and lack of special optimal situations make programming with the PIC10F200 devices simple, yet efficient. In addition, the learning curve is reduced significantly. The PIC10F series devices contain 10F200 devices contain an 8-bit ALU and working register. The ALU is a general-purpose arithmetic unit. It performs arithmetic and Boolean functions between data in the working register and any register file. The ALU is 8 bits wide and capable of addition, subtraction, shift, and logical operations. Unless otherwise mentioned, arithmetic operations are 2's complement in nature. In 2-operand instructions, one operand is typically the W working register. The other operand is either a file register or an immediate constant. In single operand instructions, the operand is either the W register or a file register. The W register is an 8-bit working register used for ALU operations. It is not an addressable register. Depending on the instruction executed, the ALU may affect the values of the carry, C, digit carry, DC, and 0, Z bits in the status register. The C and DC bits operate as a borrow and digit borrow out bit respectively in subtraction. See the SWB, WF, and ADD, WF instructions for example. A simplified block diagram is shown in Figure 3.1 and Figure 3.2 with the corresponding device pins described in Table 3.2. Alright, well here's where I start to tune out. Anyway, I guess this is a block diagram of the PIC10F200 and where to start. Here's the GPIO pins. Well, it's not that this is not interesting. It is interesting, but it's a whole lot of things that I don't know very much about all at once. On page 12, there is a pinout description. So, almost be good if I had... Okay, well I've got this on the Paint program, so here are the pinouts. And so maybe it'll make sense when I read the description, the pinout description. GPO ICSP DAT plus SYN plus function GPO 0 input type TTL. TTL is transistor logic, is a logic family built from bipolar junction transistors. Its name signifies that transistors perform both the logic function, the first transistor, and the amplifying function, the second transistor. It is the same naming convention used in resistor transistor logic and diode transistor logic. So GPO is the input type. Description: bidirectional input-output pin can be software programmed for internal weak pull-up and wake-up from sleep on pin change. ICS PDAT input type ST. CMOS is the output type. In-circuit serial programming data pin. CIN plus, I guess that's a comparator. I'm pretty sure my chip doesn't have comparators. Comparator input, it's on those two chips only. GP1, everything looks kind of the same actually to this chart. This GP1 is the clock pin, and this oscillator 4 is oscillator 4 output. This GP3 mClear VPP, I will read this. I think I might learn something. Master clear reset. When configured as mClear, this pin is an active low reset to the device. Voltage on GP3 mClear VPP must not exceed VDD. during normal device operation, or the device will enter programming mode. Weak pull-up always on if configured as VDD, positive supply for logic and input-output pins. VSS is the ground reference for logic input-output pins. And there's a legend. I is input, O is output, input-output, power, not used, TTL, TTL input, Schmidt trigger, input, AN, analog input. Clock scheme instruction cycle. The clock is internally divided by 4 to generate 4 non-overlapping quadrature clocks, namely Q1, Q2, Q3, and Q4. Internally, the PC is incremented every Q1, and the instruction is fetched from program memory and latched into the instruction register in Q4. It is decoded and executed during the following Q1 through Q4. The clocks and instruction execution flow is shown in Figure 3.3 and Example 3.1. Instruction flow pipelining. An instruction cycle consists of 4 Q cycles. The instruction fetch and execute are pipelined such that fetch takes one instruction cycle, while decode and execute take another instruction cycle. However, due to the pipelining, each instruction effectively executes in one cycle. If an instruction causes the PC to change, example go to, then 2 cycles are required to complete the instruction, example 3.1. A fetch cycle begins with the PC incrementing in Q1. In the execution cycle, the fetched instruction is latched into the instruction register IR in cycle Q1. This instruction is then decoded and executed during Q2, Q3, Q4 cycles. Data memory is read during Q2, operand read, and written during Q4, destination write. Okay, so here's clock instruction cycle. Q1, it goes on and off, Q2, on and off, Q3, on and off, and Q1, Q2, Q3, and Q4. Internal phase clock. Instruction pipeline flow. Fetch, execute, fetch, execute. All instructions are single cycle except for any program branches. These take 2 cycles since the fetch instruction is flushed from the pipeline while the new instruction is being fetched and then executed. Page 15 talks about memory organization and stacks. Okay, well, I think I'll stop reading here. Okay, I thought I should read this into the video. This is kind of an afterthought. I typed in configuration bits on the find, and I figure I should read this. Special features of the CPU. This is page 41. What sets a microcontroller apart from other processors are special circuits that deal with the needs of real-time applications. The PIC10F200 microcontrollers have a host of such features intended to maximize system reliability, minimize cost through elimination of external components, provide power-saving operating modes, and offer code protection. These features are reset, power on reset, device reset timer, watchdog timer, wake up from sleep on pin change, wake up from sleep on comparator change, sleep, code protection, ID locations, in-circuit serial programming, clock out. And I guess I'll start reading up here. The PIC10F devices have a watchdog timer which can be shut off only through configuration bit WDTE. It runs off its own RC oscillator for added reliability. When using INTRC, there is an 18 microsecond delay, or millisecond maybe, delay only on VDD power-up. With this timer on, chip Most applications need no external reset circuitry. The sleep mode is designed to offer a very low current powered down mode. The user can wake up from sleep through a change on input pins, wake up from comparator change, or through a watchdog timer timeout. 9.1 Configuration bits. The PIC10F200 configuration words consist of 12 bits. Configuration bits can be programmed to select various device configurations. 1 bit is the watchdog timer enable bit, 1 bit is the mclear enable bit, and 1 bit is for code protection. See register 9.1. Configuration word for PIC10F200. Looking at this, mclear CP WDTE. Okay, legend, readable bit, W is writable bit, unimplemented bit as 0, value at POR, 1 bit is set, 0 bit is cleared, X bit is unknown, unimplemented read as 0, bit 4 mclear, GP3 mclear pin function select bit, 1 equals GP3 mclear pin function is mclear, GP3 internally tied to VDD, CP code protection bit, off or on, watchdog timer bit, enable bit, enabled or disabled, reserved as 0. So what? 4 bits? Kind of looks like it. mclear CP WDTE. Okay, I'll read until this time's out to 5 minutes. Oscillator configurations. Oscillator. The devices are offered with internal oscillator mode. INTOSC, internal 4 MHz oscillator. Internal 4 MHz oscillator. The internal oscillator provides a 4 MHz nominal system clock. Yeah, I just don't feel like reading this. Here's all the reset bits or something.